Welcome to day 29 of our Python journey. Today we are diving into NumPy, an essential library for numerical computing in Python. We will be covering array creation, slicing, and indexing, along with some key operations that make NumPy so powerful. Let's start with an overview of NumPy. NumPy stands for Numerical Python and is the foundational library for numerical computing. It enables you to work with multidimensional arrays and matrices. The best part, NumPy is highly efficient, meaning you can perform mathematical operations on arrays quickly and easily, even with large datasets. This makes it an essential tool for tasks in data analysis and scientific computing. To get started with NumPy, we first need to create arrays. An array is essentially a grid of values. And in NumPy, we can create a one-dimensional array as shown here. Notice how we use the np.array function to create the array. You can also create 2D arrays, which are simply arrays of arrays, like the example shown here with 2 rows and 3 columns. Now let's talk about slicing and indexing. This is a way to access and manipulate specific elements in an array. In our first example, we are accessing the first element of the 1D array. Similarly, in a 2D array, we can access specific rows and columns. With slicing, we can extract a portion of an array, such as elements from index 1 to 3. This flexibility makes NumPy arrays easy to work with no matter the dimensions. When working with multidimensional arrays, slicing becomes even more powerful. For example, we can select multiple rows and a specific column at once, like this today array slicing example. Another cool feature in NumPy is Boolean indexing. Here we filter the array to only show elements greater than 3. This allows us to quickly isolate elements that meet specific conditions. Next, let's explore array operations. One of NumPy's strengths is its ability to perform element-wise operations on arrays. This means you can add, subtract, multiply, and divide all elements in an array with just one line of code. For example, adding 5 to every element in the array or multiplying every element by 2. This makes it easy to perform mathematical operations on large datasets quickly. Another useful feature in NumPy is array reshaping. This allows you to change the dimensions of an array without changing the data inside it. In this example, we reshape a 1D array of 6 elements into a 2D array with 2 rows and 3 columns. We can also flatten multi-dimensional arrays back into 1D arrays using the flatten method. NumPy also offers several functions to make array creation easier. You can create an array of zeros or ones using arrange to create arrays with evenly spaced values, or even generate arrays with linearly spaced numbers using linspace. These functions are helpful when you need arrays of specific shapes or values for computations. Now it's time to practice. I encourage you to try the following exercises. Create a 1D array and access its first and last elements. Reshape a 1D array into a 2D array. Slice a 2D array into to extract specific rows and columns. Perform element-wise operations on an array. Filter an array based on a condition like values greater than 10. These exercises will help solidify your understanding of NumPy. To wrap things up, we have learned that NumPy is a powerful tool for creating and manipulating arrays. We explored how to create arrays, slice and index them, and perform mathematical operations. NumPy is efficient and makes working with large datasets and numerical computations much faster. Now we have the foundation to use NumPy for a variety of tasks from data analysis to machine learning.